All right, hello everybody. Welcome back to the stream, the Saturday morning edition of the stream. That's kind of like a bonus stream, even though I've gotten in the habit of doing it like every Saturday, so you know how it goes. But what am I going to say? Oh yeah, so I lied to you all, and the reason I lied to you all is because I was mentioning that the next code review video is not going to be out until next week. Well, I actually decided to release it today, so that will be out in a half hour. So yeah, hopefully you enjoyed that iteration of the code review. And then I mentioned I've got a sponsor lined up for another code review video, so I'll probably be releasing another code review a week or two from today. So yeah, plenty of code review content coming for you all. You all seem to enjoy it. Anyway, before I get into what we're going to work on in the stream here, I want to remind everyone that Gunforged is available for purchase. It's my first real commercial release as a full-time indie developer. So you can purchase that if you want to support my work and leave a review if you end up playing it. And also, I've got the Survivor style game course here. And this is one of my Udemy courses, very popular. I also have a C# course. So if you want to learn how to build a complete game in the Godot engine, you can pick this up. And this is also a great way to support me. So yeah, check those things out. They're linked in the description below. And we're going to be continuing on with the game map today. What I still need to figure out is how to prevent backtracking. So what I think I'm going to do is do the Hamiltonian path, I believe it's called, through the map here to make sure that there's no backtracking, and then can add edges as necessary to make the map a little bit more interesting. So yeah, that's it. So let's get right into it. Hello, Luca. Welcome back. Good to see you. You could sleep in on a Saturday, you know. Well, let's see. I mean, why aren't you sleeping in, Adam? Welcome back to the stream. Yeah, the thing about, I don't know, sleeping in just makes me more tired than if I just get up at the right time. I don't know what that's about. Never waste a day, right? Hello, my Kundev. Welcome. Any key, good to see you. I am keeping busy, yes, trying to anyway. Hello, Tomology. Welcome. Okay, now I actually don't know if the Hamiltonian path is the correct word here. So oh my gosh, my cat is going mental right now, as our friends across the pond would say. Agent ask. How would I go about generating placing edges in a minimum spanning tree to create a path that does not require backtracking? In other words, a path where all nodes can be visited once without revisiting a node. Good morning, Bargy. Welcome. Good to see you here. How are you doing? I've been waking up early since 2003. That hasn't changed since I retired. My body just wakes up on its own now. Oh yeah. Were you deployed in 2003? Have you tried out Rider for all your C# programming? It's supported Godot for a while. I have tried that out, yeah. I don't know. There's something about VS Code that I just like. I don't know. What you're describing is a Hamiltonian path, which is a path that visits blah, 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 to create a path from an MST, blah, blah, blah. Construct the MST, I got that. Treat the MST as a tree. Pre-order traversal starting from any node. Commonly the root of the MST. Visits the node at depth first manner from the path. I am doing a Delaunay triangulation and forming an MST from that. How can I use the edges from the triangulation to create the Hamiltonian path after the MST is created. Start with the MST. Use a depth first search traversal on the MST to visit all nodes. This will give you a path that visits each node exactly once. A Hamiltonian path. Keep track of the visited nodes to add edges from the triangulation. If the MST does not include edges, you can selectively add edges to create shortcuts or improve the path. The order of nodes visited forms the Hamiltonian path. Okay, well. Generate Hamiltonian path. Okay, please specify how to add edges back into the MST based on the Hamiltonian path. I'm with you on that. Oh, with me on... Oh, no. I don't know what that's in reference to. Oh, VS Code, maybe? That's when I joined the Army and then retired 20 years later, 2023. All right, Adam. Well, I was in 3rd grade in 2003. VS Code, gotcha. Yeah, I don't know. There's just... What if you were to press me and, like, say, why do you like VS Code so much? I just like sputter like an idiot, but because I don't think there's the honest thing is I don't think that there's anything that VS Code does particularly well. Like I can't point to one feature I'm like, yep, this is the reason to use VS Code. It's just like it feels lightweight. I like the customizability. I can use it if I do web dev stuff. So I'm like using the same IDE for all the work that I do. So like I know all the shortcuts and I'm very productive and I don't have to switch between IDEs and the different shortcuts. I know you can make them similar, and then I've got Copilot in here. I don't know if Rider has that yet. So yeah, it's not that it does any one thing particularly well. It just kind of like feels good to use overall. And that's not a very satisfying answer, but there you go. You were born in 2003? Oh goodness. We're all old. You were born in 2003 too? Oh my gosh. Oh my gosh. Well, I guess I'm not that much older. I'm aware I'm the old man in this community. Yeah, that's funny. That is funny. Yep, I was born in the 90s, so I might as well be ancient. Not as ancient as Adam, but... So, I don't know. Here's how you can modify your create edges method to include this logic. This is too hard, man. I was not expecting to go right into thinking really hard this morning. Excluded edges. All right, let me think. Generate Hamiltonian path. I'm going to do something real quick. This is returning a list of nodes. If not contains node B, we're going to check. Oh, we're going to find an edge in the excluded edges list and add the shortcut there. Okay, I think this actually makes sense. So here's what I'm going to do first. Instead of trying to get fancy with adding edges back, I'm just going to draw the Hamiltonian path and see what that looks like. So we'll apply the MST. Okay. Maybe I can't do that. Optionally add random shortcuts. Okay, let's do this. Generate Hamiltonian path. Wonder why it's called a Hamilton. Why is it called a Hamiltonian path? This is your Saturday morning PBS. This is your educational stream right here. Hamiltonian path. Irish mathematician Sir William Rowan Hamilton, who studied such paths. I think that's so funny. There's just like a bunch of dudes in like the 19th and 18th century who like figured out all the computer algorithms before computers existed. I know that. I mean, it's kind of to be expected because like computer science is just basically mathematics. But Hamiltonian path is defined as a path in a graph. Like you'll read stuff about how like some dudes in the 40s figured out like this really complex algorithm that's like super common in computing now. It's just kind of funny how that works. Anyway, it's defined as a path in a graph. Oh yeah, I know that. Okay. Oh, he's finding a path through the vertices of a dodecahedron. How does that happen? How do these guys sit down with their quill and parchment and just be like, all right, I'm going to draw a dodecahedron and then try to connect the vertices? What problem was he trying to solve? Or was he just like, was it just like a Rubik's Cube for him? Anyway, we don't need to go too deep into the history, I suppose. Anyway. It's like the definition of standing on the shoulders of giants. So generate Hamiltonian path, and then I'm just plagiarizing from the AI here. Let's grab this. We're gonna get rid of this. Well, we'll keep that because that's not actually doing anything. Generate Hamiltonian path, add edges back to the MST based on the Hamiltonian. So I wonder, instead of... Let's just put this in here and let's see what it looks like. Why not? It's good to see a professional level indie developer using AI to help with programming. A lot of people have some weird opinions on the topic. Yeah, I think that AI like is very helpful for doing the rote stuff. I feel like this didn't work. Okay, I need to just... I need to... What is... Is the minimum spanning tree already a Hamiltonian path? Wait a minute. No. So maybe I should just... Okay, I'm gonna cheat a little bit. I just want to see what the Hamiltonian path looks like. So for each var, let's do for int I equals 0, I is less than Hamiltonian path dot count minus 1 I plus plus. Wait, it just recreated this. I'm gonna get rid of this MS. Well, I'm just gonna cheat here. For each var node in map.nodes, let's do node.clear connections, and then we'll do this. So this is exactly the same as what's down here. Just want to see what the Hamiltonian path looks like. That is not correct. Well, this is the problem of using AIs. Like, I don't know what's going on here, so... Let's not do this, and let's just do node A dot connect node B. Isn't this going to error? Oh, did it error? How is this not a index out of bounds error here? I don't understand that. Oh, because it's doing -1 here. Gotcha. let's see what that looks like. 1990s kid stands up, but not too fast. Our backs hurt. Yeah, speaking of which. Yay, I'm not late. Welcome, Happy Creeper. Good to see you again. VS Code is the best, except for C# or Java. At least that's what everyone on Reddit says. People on Reddit say a lot of things. Tried Godot before it was great. Yeah. Who's in that club? I started using Godot in 2017 in 3.0 alpha. I was a pioneer of finding all the bugs. Now I have that Uptown song stuck in my head from Hamilton. Oh, is ChatGPT recommended for assisting code for your game? I think it's a good tool, especially if you already kind of know what you're doing. If you already kind of know what you're doing, then it basically can just help your productivity by just doing the rote stuff for you. This is not working at all, though. Even if I were to use this path, it's not solving the problem I'm trying to solve. So I think this is kind of, I'm either doing this wrong or this is not what I want to do. What I'm trying to do is, I'm trying to avoid this situation. I want to allow the player to have a path through the map which does not require backtracking. The player should be able to backtrack if they want to, but it should not be required. A backtrack shouldn't be required if you want to visit a node. And so I've got this map fixed to this seed here. And this, the bulk of the map looks fine, except here. To get to these 4 nodes here, I am required to backtrack a couple of times. So if I go here, I have to go here to get into this branch here, but then I have to go here. There's no way to get back into the map without revisiting this node and this node. So ideally what I do is connect this node to this one or connect this node to that one. And that will that prevent backtracking? Yeah, that could prevent backtracking because then imagine there's a connection here, right? If there's a connection here, then what I can do is I can go here. Oh, wait. No, that would create a backtrack too. So I would go, I mean, I could go here, 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 but then I'd have to go back here and back to the start. So it's almost like I'd need to... Ah, I should have paid attention in college. The reason I need to use, so I'm doing the triangulation, so I'm doing a Delaunay triangulation, I think that's how it's pronounced. The reason I'm doing a Delaunay triangulation is to make sure the edges don't cross each other, right? So I'm basically scattering a bunch of nodes around, and then I'm triangulating them so that every node is connected basically to its neighbor nodes through a triangle. And then what happens is there's a minimum spanning tree that is generated. And I can probably show what the minimum spanning tree looks like. A minimum spanning tree is generated from those edges. And so that looks like this. So the minimum spanning tree is basically just a very direct path to each node on the tree. But this doesn't create any loops, right? So From that minimum spanning tree, I have all of the edges that were excluded when generating the minimum spanning tree, and then I need to selectively add edges back to reduce the backtracking. So let's just do one step at a time here. Let's put the Hamiltonian path back in and see what that does. See, that doesn't do anything. I have a feeling this is not what I want to be using. What is a Hamiltonian path? Let's see. A pre-order traversal visits each node exactly once in a depth-first manner. Is the start node important? Let's see. Is the start node important for generating a Hamiltonian path? There's probably one issue with using AI for programming. Understanding and internalizing information is not optimal, at least for me. Yeah, true. Kitty, yeah, he's right here. Thanks for your insight. I heard ChatGPT makes more buggy codes once your projects gets bigger. Yeah, I mean, I think the danger with using AI is that it's a form of technical debt, because if you rely on the AI too much, specifically to like design your systems or architect your code, you're gonna basically have no knowledge of how your code is working. That's why I use it for very narrow things like doing specific algorithms. But I'm still the one controlling the overall design of the code and how the data flows through the system and all that stuff. Hello, Kineas. I'm paying attention in college, but I still don't know what you're doing. Oh, it's already starting with the start node. Well, what in the heck? I don't know what this is doing. Is this ever even doing anything? Let's see. It's not. This code is literally never running. Okay, let's try something else. I'm trying to create, let's get rid of this stuff. I'm trying to create a map graph of nodes where each node can be visited without backtracking. Analyze this class recommendations about how to accomplish this. I don't think the Hamiltonian path is working. The DFS approach may skip nodes if they are not reachable from the starting node, but they are reachable. If you want a Hamiltonian cycle instead of a path. Oh, interesting. Wait, that's not going to work. This is not going to work. I don't think the AI is being helpful. Let's try, let's use Claude 3.7 Sonnet. Backtracking. One of these days. Oh, wow. So Claude 3.7 Sonnet is doing a lot of different stuff here. Oh my gosh. What even is going on here? Is there... Okay, I'm gonna get rid of this stuff. Let me try something. Maybe if I try a more narrow solution. After the code in create edges is run, is there a way to detect nodes that require backtracking to visit? If so, recommend a more narrow approach to fix the backtracking by adding some excluded edges back into the graph. The key indicator of backtracking requirements is leaf nodes, nodes with only one connection. But that's not true. That's not true at all, because there's a non-leaf node that will also require backtracking. What in the world? So like this is not a leaf node, but, well, maybe actually if I just, yeah, maybe, okay. I apologize for getting angry at you, AI. No, I don't, actually. Detecting backtracking issues, okay. Find best edge to avoid backtracking. What is going on in here? Why is it using distance? I don't like that you are recommending to use distance to avoid backtracking. There should be a much more reliable way to do so without doing any distance calculations. I've heard that Google 2.5 Pro is also pretty good. Oh, Gemini, yeah. Can I use Gemini in here? Oh, I can. Claude 3.7 moment. Gemini is best. 2.5 is the best benchmarks in coding. Trust a vibe coder. Okay. Claude 3.7 likes to do stuff you didn't ask to. I noticed that. I know I'm right. Let's see. There's a more direct way to blah, blah, blah. Try to find an edge that connects to a different node. So I've got the leaf nodes already. So I was on the right track when I was using leaf nodes here, I think. Valid excluded edges. Okay, so I'm going to rewrite this myself a little bit. We don't need this get ancestors. Don't need this random edge. Not valid excluded edges dot any. We'll continue. Get the node that this leaf is currently connected to. It could be connected to multiple. This is good. Better edges. Valid excluded edges. Current connection. This, I should say, return. Yeah, let's do this. Return. Leaf.connections.first. Why is it using leaf.connections.first? Where not leaf.connections.contains other node. I think that's better. So we're looking for all of the excluded edges, the edges that have been removed from the map. Where the leaf is not already connected to that edge. Is that right? Or where the leaf is not already connected to that node. Okay. That doesn't make any sense, does it? Anyway, whatever. Edges to consider. What is this even doing? Better edges.count. Okay. So basically it just looks like the code that I had before, except instead of choosing a random edge always, it's just going to find an edge that maybe is a little bit better. I don't think this is going to work. I have no confidence in this solution. Nope. Okay, I'm not going to change. What does this current connection do? Why is it doing leaf.connections.first? Oh, that makes sense. Wait a minute. Okay, I'm not going to second guess the AI right here. Let's just do this. So the leaf definitionally only has one connection. I was just wondering why it was doing first. So there we go. It's probably gonna do the same result though. I think it's functionally the same. Yeah. What in the heck? I mean, this whole problem would be solved if I just added an edge here and added an edge here. But it doesn't want to do that for some reason. What I was trying to do last night or yesterday is I was trying to identify the sort of ancestor node that required backtracking. That doesn't help though. I need an algorithmic way of saying I want to connect to this node because that's going to prevent backtracking, and I want to connect to this node because that's going to prevent backtracking. But for some reason, the leaves always want to be connected to this node, which is not helpful. I mean, I guess it's kind of helpful in a narrow sense because... yeah, I think I need to look at the graph more holistically here. What game are you making, bro? Hello, Sai. I'm making a collectible card game, roguelike, auto battler, grid inventory management game with a necromancy / alchemy / medieval science theme. And right now, working on an overworld map where the player can choose encounters. So like this is a combat encounter, so I can go there and I get into a combat here. Thoughts on DeepSeek? I don't know anything about DeepSeek, really. Hello, Snupbill. Thank you for the IDR 10,000. Very much appreciate that. Thank you, thank you. With the message Yummers. We all love the message Yummers, folks. Yummers, there it is. I was doing a MATLAB research thing a while back and found out that holding your breath when compiling will increase the chances of your code working by 20%. You should try that. Oh, yeah, give it a try, for sure. Yes, Neozoid, welcome. Always good to have you here. I want to learn GDScript, but how do I learn this? Just practice. Just practice. That's all. I mean, it's not a very satisfying answer, but you just have to sit down and work through the issues and bang your head against the wall for a while. That's the proper way to learn anything. My video just released. Excellent. Hopefully nobody drops off. You can watch the video after the stream. Oh my gosh, I don't know what to do here. I'm not clever enough for this. I think issues in the nodes on the left don't actually require backtracking. You can go down to the loop on the right and then go to the loop on the left with your 10 moves. Yeah, that's true. So you could go here all the way around this way. I mean, that is an interesting point. Yeah, I guess I just really don't like these kinds of things happening here. Because if you don't want to waste moves, then you'd have to plan these to be like the end of your traversal here. So let's see, if I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so I wouldn't be able to reach those. But what I could do is I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, yeah. That is interesting. Are you suggesting that I leave this in place and just make the player have to plan around that? Are you suggesting that I don't fix this and that I just call it a feature and be done? Not actually sure on how the algorithm actually works, but might catch that. I was watching your stream from yesterday after you stopped streaming. Not sure how far you got since then with the whole ancestral node thing. I think the ancestral node thing was a dud because I mean, I can get the ancestors of a node, like a leaf node, for instance. I mean, there's a sense in which like every node is the ancestor. But what I really need to do is I need to identify the first node where after you pass it, backtracking becomes required, which is a little bit more tricky to do. But that still doesn't help because that doesn't tell me which node I should connect to. Although it might. This is actually a really tricky map because Yeah. Shoot. Hello, Charlie. Welcome back. Yeah, you've been here. Welcome back. You can still probably identify choke points and open them up. What if free backtracking is a thing? Like you start with a free backtrack, and if you defeat like a tier 3 combat, you can earn another free backtrack or something. Lean into the error. Yeah, I've been thinking about that. I just think that even if I made backtracking not like just have no effect, like if I just said, yeah, your backtracking doesn't count to one of your moves as one of your moves, it still is kind of just like weird unless there's another gameplay element to backtracking, right? Because I'll go all the way over here, clear all the nodes, and then if I want to get back to a node that I haven't visited yet, I just got to click a bunch of times, which is kind of weird. So I still really like the idea of backtracking being something that costs one of your movements, which you don't have to do ever in the map, but you could do if there was an encounter that you wanted to avoid. So it's kind of like an more organic way of like imposing a penalty on the player for avoiding maybe a particularly tough node, and it's also a way of imposing a penalty on the player for like poorly planning your route. You know what I mean? It's like a very natural penalty. So I do like that. I'm really dead set on trying that. I don't know. Can I, let me try something. This is a visual representation of the map generated in Run Map Generator. The area highlighted or circled in red is a region of the map that requires the player to backtrack if they want to visit any of the nodes in that region. Recommend ways to fix this such that backtracking is not strictly necessary. I wonder if it will do well with the image. What? Collect a region. Okay. Like you didn't think this whole thing out before you started working on it? Well, I mean, I don't know how you're supposed to plan out an entire algorithm before you work on it. You build a building one brick at a time. So what's wrong now? Yeah, I'm just trying to prevent backtracking here. Oh, I meant the gameplay mechanics. Yeah, I mean, it's the same concept. Like, I don't think you can plan gameplay mechanics ahead of time. I just don't think that works. Like, you could sit down and write a grand game design document, but it's like pretty much useless until you actually see how it works together in the game. So I don't even bother. I just build the things up as I want them to be, and then if they don't work, I change them or remove them. Here's a method to find choke points. For each node, have a var of distance from spawn. If each attached node except one is farther than spawn. If each attached node except one is farther than spawn, the point is a choke point. Well, the problem is I don't want to use distances because I'm using a triangulation. So I already have edge data. Like if I don't generate a minimum spanning tree, where is this? If I don't do any of this, then I don't have that problem, I don't think. So here is the triangulation, right? Basically every node needs at least 3 connections. That might be it. That might be it, actually. So anyway, this is what the triangulation looks like. So there's no required backtracking in here at all. But the problem is that's not very interesting, right? So the point of generating a minimum spanning tree and then adding edges back in is that it creates a little bit more variety. But I think Adam might be right. No, I don't think that's right, actually. Oh, maybe it is right. No, that's not going to work, because this one has 4 connections here. And this one has 4 connections here. But it's creating a loop. Now, I guess if I took the leaf nodes and I made sure the leaf nodes had 3 connections, that might actually fix it. So it's not that every node needs at least 3 connections, it's the leaf nodes that need 3 connections. Because this is not a leaf node, this doesn't need 3 connections here. And actually it's not possible for this to have 3 connections, I don't think. Because this is at the edge of the map, right? So I guess the leaf nodes just need to have 3 connections. Okay, you might be onto something, Adam. Let's see. I'm gonna close this AI. You're gone, you're dead to me. Oh, but here's the problem. Like, yeah, it needs 3 connections, but that doesn't tell me which node it should go to. Because I could put it here. And that wouldn't solve the problem. Like, this one would have to be connected to this one, which makes sense. But this one could get connected to that one. Oh, wait, maybe that would work. Because if this was connected here, and this was connected here, then I could go this way, and then I could go down and then this way here to avoid backtracking. Okay, let's try it. Let's try it. Now, hold up a second, though. Is that going to potentially produce errors in some cases? Is that potentially going to produce errors? Because the problem is, like, what if this is a leaf node here? Oh, you know what? Actually, I'm wrong. This could be a connection here. So yeah, no, yeah. Yeah, each vertex should have 3 edges. Okay, I think it'll be fine. I'm just thinking here for a second. Okay, you know what? I'm gonna undo. Have I made any useful changes here? I don't think so. Let's discard that. Let's get, what did I do something wrong? Get rid of this get ancestors, get rid of this collect ancestors. Okay, let's change this. Can I index a hash set? No, I can't. Okay, excluded edges, let's do this. All right, never mind. Let's not get too fancy with it just yet. I'm not sure how to define ancestral nodes here. Usually they're the ones between the leaf and the root of a tree, but this graph is non-directic and cyclic, so I'm confused by the comment. Yeah, I mean, that's the problem, right? It's like, what is an ancestor in a non-directed and cyclic graph? You know, like everyone's an ancestor of everyone else, basically. If everyone node has at least 3 connects, you are back at triangulation. Right, it's not, yeah, so right, it's not every node has at least 3 connects. I'll just make sure the leaf nodes have at least 3 connections. Oh, just joined, what's this about? Generating a map for the game. Just find a Hamiltonian path before starting to remove nodes. I tried that, it doesn't work. At least not the way that I did it. Right, I'm not dealing with just edges. I have a triangulation, so I have a list of valid edges that I can add back into the map. I don't think a single connection between subgraphs is going to solve the problem, because then that's going to create, that's still a backtracking problem, right? Unless I'm misunderstanding. 2 fully connected subgraphs where everything is connected to everything. Just add a single connection between them. Have you ever made a multiplayer game? I have, yeah. My game Collabins on itch.io is I added multiplayer to it, but I'm also making a multiplayer game for the course that I'm working on. So yeah, it's like elite code questions, very tricky. No, I appreciate the input for sure. That your comments are giving me ideas to work with here. Hello, pseudonym. I think this is going to work. I think this may not be the most elegant solution, but if I just look at the leaf nodes and make sure they all have... I mean, a leaf node definitionally has 1 connection. Is that true? Right, so this is what the leaf nodes look like. I guess they don't need to have... the easy solution is going to be to make sure the leaf nodes have 3 connections. So basically re-triangulate the leaf nodes. It's not going to be as elegant, because what I could do is say, well, I only want to connect this one and that one. But the problem is, yeah, that goes back to the problem, which is I don't know how to identify that this node is more appropriate than this node. And it goes back to like the ancestor thing where it's like, well, I could just say, don't add a connection to an ancestor node, but then it's like, what is an ancestor node, you know? In this case, it seems pretty clear. You could say, well, just trace all the nodes to the start using like the minimal path, right? but I don't think that's guaranteed to be the case. I don't think there's guaranteed to be a start node in sort of like the ancestor list, you know? Let's just try the triangulation thing. We'll see how that works. Leaf dot connections. Valid excluded edges dot remove random edge. Add shortcut random edge. We got to make sure to remove any edges that we add from the excluded edges here. All right, let's see if that works. So yeah, I think, I mean, that fixes it. I'm going to do some things here. I'm going to generate 1,000 maps and make sure that that while loop is not going to cause problems. I don't think so. But, oh. Just going to generate 1,000 maps and see if it crashes. Let's do 10,000 maps. Why not? Print it 10,000 times, whatever. Let's see. Let's see what happens. For the last month, I've been struggling to get my game on Steam. Why is that? Output overflow. Oh, that's fine. It's actually pretty quick at generating 10,000 maps. Let's do 1,000. There will be leaf nodes inside the graph, though. I don't think so. I don't think a leaf node is just a node that has one connection, which should not really happen inside of the graph. I've gone through review 3 times, and each time they say something is wrong with my graphical assets, but I find their instructions confusing. Do you find that problematic, or was it easy for you? For Gunforged, it was like as soon as I submitted it, and 3 days later, it was like, you're approved. So I'm sorry, I don't know what the issue would be. Maybe it's a hardware issue. Maybe it's not running correctly on a specific platform. Base the ancestor off of the MST. I guess that's oh, I see. Interesting. That might be something to try. Sorry if I'm nosy. Do you have an estimate on when you're going to release a new course? I love the Vampire Survivors one. It'll probably be out in June at some point. The MST has a unique path to each vertex, so ancestors are well defined. That's a good idea. It's been 4 live streams now and you still don't have a minimum viable implementation. Yeah, if it takes 10 live streams, so be it. Boom, perfect. Remember to log the problematic seed. Yeah, I have not changed that seed, but also that seed was committed into the Git history, so I'm not going to lose it. But good idea. Oh, the store page assets. I see. I want the art and fun stuff again. If only games could be just art and fun stuff. If only. So the good news is that when I generate 10,000 or 1,000 maps, it's not crashing. So that's good. I always get nervous with while loops, but I think the while loop has enough conditionality here where it will not be a problem. Now, using the minimum spanning tree to determine ancestors is a good idea. I'm kind of tempted to try that. Okay, I'm gonna go here. I'm gonna have the AI do this for me. Modify get ancestors and collect ancestors to use the MST edges to find ancestors. Let's see what this does. Minimum spanning tree. Uh-huh. What? Oh. I'm in the wrong spot. Run. Oops, I just closed it. Run map. Here. Okay. Why are you adding a get method if you made this public? Why would you do that? Okay. Let's see what this does. Let's see what this does. I have no clue. Oh, do I need to modify this now? Valid excluded edges, yep. Random edge. I have no clue how I'm going to identify this correctly, but let's see what happens. I think what I should see is that this should be so it should have 3 ancestors or 4. It has one ancestor. Cool. It has one ancestor. I still don't know even what that means to use the MST edges. Like what? Because it's not like the MST is not directed either. So does it even make sense to have ancestors even if I just use the MST? I don't think that makes sense. If I just generate the MST, this is the minimum spanning tree. So would it just have to terminate in the start node? I don't think this is going to help. So I could say, like, yes, if the start node is sort of like the terminator point, then this leaf node here would have this, this, and this as an ancestors. But I still don't understand how that would even help me. Because it doesn't tell me which node I should connect the leaf node to. I suppose what I could do is I could check if the ancestor and the leaf node both have edges that lead to a node in common. So if I detect that there's an edge here that goes to this one and an edge here that goes to that one, that's kind of the way that I can infer that if I added the edge to the node in common. I don't know if that logic will hold up though. That's the thing. I have no idea on data structures, yeah. I literally increased the size of the text for you, Kinyaz. I'm a JavaScript programmer. My game was done in them. Might be good for me to learn Godot though. Gunforge looks so pretty. Maybe I can learn a lot from this channel. I hope so. We'll see. We will see. Yeah, it's VS Code. Define a node as the root node of the MST, and the ancestors are any nodes on the unique path from the root node to the node. Yeah, it's a tree, so this would be the start node. Something not in the list of ancestors. Oh, I see. Right, so I would take... Okay, that makes sense. So I would get a list of the ancestors, and then I would say, okay, find all of the potential edges where the connection on the other end is not in the ancestor list. The question, though, is that going to work? That should work, right? You should connect the leaf node to any node that's not an ancestor. Gotcha. I'm half blind. I'm sorry, I guess I shouldn't laugh if that's actually true. But I saw your second comment, so I'm not sure if it's true or not. Hello, Newness Games. Welcome. Good day to you as well. Okay, well, the problem though is that it's not actually getting the list of ancestors properly. Like, it's just returning one ancestor for some reason. Get ancestors is only returning one ancestor for the leaf node, but the expected output... Oh wait, I need to... So the MST needs a root, doesn't it? Minimum span. Oh, this is not a class though. This is just a list of edges. I don't want to add directions to the freaking edges. No. Ugh. Why do I? No, I don't want to add directions. No, 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 no. I don't know. Stop. Stop. Do not make the MST directed. Make minimal changes. Oh, thank you. You should have given me the simpler approach first. What is it doing? This doesn't seem right to me. Okay, I'm just gonna write it myself. This is ridiculous. Now watch me struggle with this. Okay, anyway. List edge, MST edges, the start node, and then I'm just going to call this like the run map node, root node. Ancestors equals new hash set. Do I want this to be a hash set? I probably want this to be a list, right? So it's ordered. Collect ancestors, start node. Let's pass in the root node, MST edges, return, list run map node. Okay. Start node, run map node, root node. I want to reorder this so that it matches a little bit better. Not super important, but that's all right. Hold on, it is getting chilly all of a sudden, BRB. Alrighty, to close my window. Collect ancestors. Okay. Current node.connections, that's probably wrong. Ancestors.add current node, why should it be? It shouldn't add itself as an ancestor, but I guess it's fine. It's not really going to have an impact. I probably need to keep a list of... connected node in current node.connections if ancestors.contains connected node return, or not return, continue. If MST edge is any equals current node. Did I do this wrong? There. But I also need to make this terminate if current node is equal to root node. Then we're just going to return. I think that'll do it. Get ancestors, MST edges. So map.mst edges, leaf, and then map.start node. All right, let's see if that works. I don't know. How old are you, guy? Are you talking to me? I'm 30. I am 30 years old. Am I the only non-developers here? You could be. Probably. I mean, I think these streams are generally more popular with developers. There we go. Why is there 5 ancestors? Is that correct? Let's just go forward. So that would be, it's including the start node. So 1, 2, 3, 4, 5. Oh, okay, it's working. I wrote the code better than the AI did. Excellent work. 1, 2, 3, 4, 5. So it's including itself as an ancestor, which is kind of weird, but I suppose that's okay. So now we've got the ancestors. Okay. All right, we're closing in. So we got the ancestors here. I'm going to change this to equals 0. Continue. So we got the ancestors. So now what I need to do is find an edge. Right. So what I want to do is actually want to get the ancestors first. Get the ancestors first. We want to get the excluded edges where this is true. Hold on a second. Var non-ancestor edges is equal to valid excluded edges dot where not the problem with this is that the leaf node is included in the ancestor list, which is not great. So what I could do is I could handle that in here in this if or this predicate here, or I could just make it so that the start node is not added as an ancestor, because that doesn't make sense, right? But that also is going to be tricky. So I think I'm just going to write this out instead of trying to be clever. If x.node A is equal to leaf, then we need to return not ancestors contains x.node B, else, yeah, I think that's right. So the problem is my edges are, there's only one edge, there's just one edge connecting 2 nodes, and there's no directionality to it. So like node A could be the leaf, so the node A of the edge could be the leaf, or the leaf could be node B, so I need to handle that. So if node A is the leaf, I want to ignore the leaf and just check the other side, node B, and say, okay, node B cannot be in the ancestor list. But if node B is the leaf, then I need to make sure node A is not in the ancestor list. I think that's going to work. And then if I do random edges, non-ancestor edges, so let's do this. Let's get rid of that. If non-ancestor edges dot count is equal to 0, continue. Random edge, non-ancestor edges, excluded edges.remove random edge map.add shortcut random edge. I think in practice, well, let's just see what happens. I don't know. Is it going to work? Let's take bets. Is it going to work? Sure, working, you can always have a failsafe for when there aren't viable connections in other branches backtracking to an ancestor node. Fanfi Clover. I have those big nerd glasses. Very nice. Big nerd glasses are awesome. Need to tell it to have a start as a root. Yeah, okay. I'm a little bit behind on chat. Heard GitHub Pilot has a bad reputation for generating bad codes. I think Cursor was much better, but I can't use Cursor for a variety of reasons. Well, not a variety. It's just the C# dev kit didn't work in Cursor. It broke. If you have a list of each direct ancestor, then you can just loop backward through all the ancestors to reach the root to collect them all. Nice. You're also not a developer. What is an ancestor in this context? It's any node that precedes or that is required to be visited to get to the leaf node. Yeah, that's correct. Does the unique path have to be one path? Well, in a minimum spanning tree, yes. Minimum spanning tree is like sort of definitionally that there's one path to each node. Oh, it broke. Index was out of range. Oh, I don't like to see that. Oh, I know what I did. This needs to be non-ancestor edges.count. That's why. Oh my goodness. Did it work? And I can make this more interesting too by saying var edges to add is equal to mathutil.rng.randi range. I could add either one or two edges instead. And then for int I equals 0, I is less than edges to add, I plus plus. And then we'll do non-ancestor edges.remove random edge. If non-ancestor edges.count equals 0, then break. Goodness gracious. Goodness gracious. So I don't think that made a difference in this case. I'm actually going to just bump this up to 2, and I want to see what happens. Because now, instead of just adding one edge, I could have a chance to add multiple edges as well, just to make it a little bit more spicy. Oh, that didn't work. Why didn't that work? Oh, I can't add more than one edge because it would be added to the ancestor. Ah. So I see. So that basically just did nothing. Cool. So I would have to do that. I guess it's fine. I mean, I could do another step like this where I go in and add a random edge, or I could do it. I mean, I could optionally add one of these to valid excluded edges. Let's try it. If mathutil .rng.randf is less than 0.5. Random edge Yeah, let's just see what that does. So I could just randomly add an edge to an ancestor node in there. Yeah, there we go. So I've solved the problem of the backtracking, but then I've also got here, I'm just go ahead and like randomly add an edge back to an ancestor here. And that works great. And if I were to bump this up to 0.75, we might even see more here. Yeah, that created a much different graph now. So this was a leaf node here, and it went ahead and added an edge here, which is perfect because that's a non-ancestor edge. But then it also decided to randomly add an edge to its ancestor. So that just makes the map a little bit more interesting again. I'm going to bump that back down to 0.5 though. Sweet. Very cool. Alrighty. I think that basically covers that. I'm going to get rid of the fixed seed and run it a couple times, but fix leaf nodes. That was quite the ordeal. But where am I actually setting that seed? Let's get rid of the seed there. We'll just randomize it. Yay, excellent. Yes, we're the real chat GPT here. Yeah, thank you, chat. The most powerful AI of all human brains. Which wouldn't be AI, I guess, but yeah, very helpful. Thank you, everyone, for talking me through this stuff. This is an interesting map. We got a lot of parallel lines here. That's cool. No leaf nodes too, right? We won't see any more of this. Do some cool art now. We might. We might. I have 12 hours of computer science every week. It's not fun. I finally got time to get into your course. Really well designed, but I'm on lesson 4 so far. Very nice. Thank you, Artem. What's the name of your font? By the way. In the editor, it's Cascadia Code. It's the Microsoft font. Uh-oh. We have a leaf node here. Oh no. We have 2 leaf nodes. Oh no. Oh, is it counting this? Shoot. We might not be out of the woods here. What is this seed? We are not out of the woods, it appears. I'm not going to work on this probably much more because I'm getting sick of it too, but I'm curious to see. My collect ancestors probably is not working properly. So let's see. I think what's probably happening is it's counting these as ancestors. So this is a leaf node, and this is a leaf node. I wonder if these are counting each other as ancestors. This is probably why the graph needs to be directed. I think so, yeah. So I probably need to make the minimum spanning tree a directed graph instead. So that way, I think right now it's probably just considering all of these things here as ancestors of these nodes and so on. That's probably what's happening. So, but if I make it a directed graph where it's just pointing in a direction, then I can just follow the directionality back to the root. And that would probably fix it. That same thing is happening here, I think. So this is being registered as an ancestor of this, even though that doesn't make any sense. And that's why those regions are not being connected to each other. So maybe the AI was right. Maybe I need a directionality to that MST there. Yeah, so that would be the reason, probably be the reason why these are not being connected to each other either. I bet you this edge goes away if I remove that random code. If I remove this, I bet you that becomes a leaf. Oh no, it didn't become a leaf. Oh, you know what? Oh, it's probably, yeah, I'm probably right. It's just that I'm adding random edges in here as well. I wonder if I should add random edges after the leaf node stuff. I'll have to test that actually. But if I get rid of these random edges here, oh, you know what? That might screw up the map generation. Oh no, it won't. Right, okay. Right, so these two things are not being connected to each other, and these two things are not being connected to each other because this is being detected as an ancestor of this node, even though that makes no sense. And this is being detected as an ancestor of this node. This is being detected, or this node is being detected as an ancestor of this node. It might even be doing that down here too. So yeah, I think I just need to make the MST directed, and then that should fix that problem. Because once the ancestor list is correct, I think it's just that the ancestors are wrong. So that's okay. That's fine. Can you up the contrast between path and background? It's hard to see. I mean, it's hard to see on YouTube, but I think it looks fine on my screen. We'll see what playtesters say, but I can't, I mean, there's nothing I can do to up the contrast, you know, except for change the color palette. Generate the triangulation, generate an MST, and then remove the non-MST edges, and then you can check random non-MST edges, and then you can check if an edge you want to remove will become a leaf. That is a good way to do it. Is that a good way to do it? I don't know. I'm running out of brain power already. Why are leaf nodes bad? The leaf nodes cause unnecessary backtrack. So in order to visit a leaf node, it's required that you backtrack to go back into the map. Which is something that's just a gameplay goal that I want to avoid. Might be able to just save the ancestors while generating the MST without making it directed. Save the ancestors while generating the MST. Okay. What Jude says also sounds good. You already know how many edges are connected to each node, so if you have two edges, you can't remove one or you will make a leaf. Okay, I think the problem here though is that, so if I generate the triangulation, every node is basically going to have at least two edges, right? So generate the triangulation, do the minimum spanning tree, randomly remove the triangulated edges that are not MST edges, unless the removal of that edge is going to make a leaf node. And then I can go in and randomly add edges back in just for flavor. That does sound simpler. Then I wouldn't even need to do the ancestor stuff, right? Maybe I'll try that. Not right now, but I'll try that. That's a good idea. So yeah, triangulate, do the MST, randomly remove non-MST edges, make sure not to remove any edges that creates a leaf node. And then that's it. Yeah, it sounds reasonable. Instead of removing and then adding, just play around with how many you remove. Well, no, because I do want to add nodes back in, I think, because... Oh, maybe not. Yeah. Yeah, because the triangulation creates the maximum number of edges that I can have. So, yeah, it would just be a matter of just randomly removing edges. Yeah, that sounds much simpler. Maybe I'll try that. Yeah, that's a good idea. I'll try that for sure. That'll be my, I would say, my afternoon experiment, but I have a course content to produce this afternoon. All right. Well, there's a lot to do here still. But I think that'll be it for the stream today. So no art today, unfortunately, Kenny has. But on Monday, probably we'll be done with this, the data sort of / computer science side of generating the maps, and should be working more on gameplay and art on Monday. So definitely looking forward to that. But yeah, that's going to be it for the stream this Saturday morning. The new code review video is out. So if you're interested, please go watch that. That might actually take you to the previous one where you can just have blobs that are separated by choke points. IDK, that stuff's tricky. Oh, would it do that? Yeah, because a choke point is a backtrack too. I don't know how I'm avoiding that right now though. I have no idea. Just gonna have to play with it. But anyway, thanks everyone for your support. Thank you for helping me think through this stuff. And yeah, again, check out the new code review video that just went out an hour ago. Hope you enjoy it. And I'll be back at it Monday at 10 a.m. Eastern. All right, see you then, everyone. Bye-bye.